Well, hey guys, welcome back to the channel and welcome back to video number 3 in the build series of the Skymaster gigantic Russian SU30 aircraft. We are getting back into this thing, continuing with the back end, so let's dive back in to the aircraft. So as mentioned in the beginning parts of this build, we are following the manual just to make it simple and kind of go with the flow. The manual does make sense. Last video, we got the wings completed on the aircraft. That was a big thing that we got done. Gear was reinstalled, so the wings are complete. This video, we are starting off with the vertical stabs or rudders. That's the next thing in the manual. Okay, so the rudders themselves they're kind of a unique system. So there's like this servo arm here with the slot, which we've already taken a look at, this guy right here. And there's these pins like this that mount in the servo arm. And when you put the rudders on, vertical stabs on, those pins interlock with the aluminum servo arm, which is cool. So, or the aluminum surface arm, I guess is the better way to say it. So we're gonna pull our rudders out, clean up the table a little bit, and let's get going on them. So rudder system is pretty darn cool on this plane. So getting the surface off is important. There's a hinge pin here, comes out the top of the aircraft, and it comes all the way down. Now the rudder operates with a bell crank. So it's essentially this setup just like this. And the bell crank goes all the way through this rod here and comes out the bottom side. Now in order to get this bell crank through, the actual shaft here, operating shaft, needs to come off. So we're going to undo the Allen key, we're going to take the shaft off, we're going to check and make sure that it's nice and tight fit and everything, and we're going to get our shaft installed. And then we will reinstall the operating shaft here. We're going to do that to both surfaces. And then the other thing that's nice to see is the arm here that fits around that makes the servo operate or operates from the servo. Really nice fit as well. So there's lots of space here for this to compress. I think we're definitely going to put some red Loctite on this. Once it's all set up and everything, there's no reason for this to ever move. So we'll put some red Loctite around the two joints there where the shaft and the arm here meet and get that tightened up nice and tight. Now, if this does ever need to be replaced because of excessive flights, this is aluminum. The pin that goes through here is steel. So this technically would wear out first. And I mean, with some heat, you can get that off no problem. Okay, so we've got our shaft installed in the rudder. This is actually gonna be pretty tight to do up the Allen key. Now, of course, we did the Allen key up and it pre-marked the shaft, and we're just gonna add a little bit of a flat spot there. You gotta remember that the shaft here sits at an angle, so that Allen key actually comes and intersects with that at an angle. So you don't need much, but that's just gonna make sure that that shaft doesn't move ever when we don't want it to. All right, so one of the struggles here is getting to this Allen key. Now, if they would have moved this horn up just a little bit, like maybe another ½ inch, we'd be able to get something like this in there, but getting a tool in there is going to be virtually impossible. So I think we're gonna have to make our own tool. So generally what that means is we'll take an Allen key like this, cut it down to just a tiny little stub. All right, so tried a bunch of different things, and ultimately I just ended up cutting down one of my 2mm Allen keys. So cut quite a bit off so we have a good fit there, and we're able to tighten that down. I got about 3/4 of a turn. I tried as much as I could with a ball end, and then I tightened it another 3/4 of a turn with this tool. So it's pretty important that you get that done properly. Also make sure you put some light lubricant on the shaft here as well. I believe this is carbon inside here, so but we want to put some lubricant on that shaft and make sure that it rotates freely. All right, so we've got one rudder done here, fairly straightforward. Before I put the arm on, I made sure I taped the vertical stab or the rudder surface so it's perfectly straight in line with the vertical stab. And I have not permanently fastened the arm here. What I'm going to do is I'm going to install the servo and just check our height and everything and position and make sure that we're happy with this. So we don't need to do this permanent because maybe we need to slide this a little bit towards the actual surface or keep it where it is. I don't know yet. So we'll leave this for a little bit. All right, so we're going to confirm that this picture is correct, but if you look, there's a hole here which is at the rear of the aircraft. So the rudder output shaft goes away from the hole, the servo shaft, operation shaft goes away from that as well. So our hole is right here, that's our fixing hole, so our servo output shaft goes away from the hole and the arm goes away from the hole, which makes sense because there's our actual operation shaft right there. So I'm just going to put a mark here, front and back. So visually we've got a rough idea when we put that servo in if we're in the right position. All right, so in order to fit the servo through this hole, we're going to need to open it up a little bit. The hole is just way too tight. So what I've done is I've installed the vertical stab on this side. Just took my pencil mark because we can only get it in so far because our bolt is sticking right there. But I just took my pencil and drew a line on the base so we know how much material we can remove. And then on this side, the vertical stab essentially sits flush against the outside skin. So we do have a little bit we can take off of there. So we just want to open this up just enough to get the servo in. Obviously, we need to get the servo in there somehow. And then what I did is I put the servo on top of the opening and just traced off the side of the servo. So you can see the servo doesn't need quite as wide as we can make it. And I ran it just a little bit in on this side. So we should have a decent amount of room there now to get that servo in. And we might have to do some cleanup down below there. We've got a whole bunch of excess glue, which I think will impede the servo from being able to go in there, and I think even right there as well. All right, so to clean up the inside here, we're going to use our Dremel with our extension on there, and we've got an aggressive carbide bit. And what we're really starting to clean up is the glue on the outside edge here, so that's going to prevent us from getting our servo in. The rest of the pocket should be fine. We can adjust it as we need to, but it looks like it's the right size. So we got the servo in, the arm's just on there so we can check our measurements here. So I'm going to take the vertical stab, place it on, and just kind of see how our fit is. We don't exactly have a great look at it from this side, but if you look, there's holes right there through the former work, so we'll be able to see it from the inside, from the exhaust side. All right, and there's a shot of the inside. So we've got some good clearance happening between the two arms. I think that is probably good. We have to check and see how much space our nut that goes on there takes up. So we may want to move that aluminum arm up a little bit, because if we put a nut on the top side of the carbon arm, it's going to probably interfere with the aluminum arm of the rudder. And then our initial measurements here are fine, but this line right there that I drew actually lines up with the center of that arm now that we've got it tucked in more. So I need to adjust my servo output position. I'll try and get this lined up for you. Just a little bit more there. So we want to kind of go back probably 2 millimeters from my white mark that's on that arm currently. So everything in our back end here, we're going to upgrade the screws to these bad mamma jammas. These are awesome Allen head, pan head wood screws. So that's where we're going to be putting the rudder surfaces in, along with the horizontal stab surfaces. And the other thing that's nice to see in the whole back end here is very thick aircraft plywood. So we've got plywood in the back here that's a nice tight grain, and it's about looks like 3/8 thick if I had to guess, and especially on the horizontal stabs there. So naturally, when you have a situation like this where you've got a pin going in an arm, there is generally going to be a little bit of play. Now there is just a hint of play here, like if I'm going to give it a number, 0.5 millimeter in play. So it doesn't seem like a lot when you've got a little arm and a little pin. But what happens when this little motion translates to the actual surface? The end of the surface has probably 3 to 4 millimeters, 3 millimeters of play each direction. So we need to get rid of that. That's the kind of issue that's going to cause flutter. So when you look at this, you could try and sheet this with something. Shrink wrap might work, but it's not going to be a permanent solution. So let's take it one step further. So all I did in this case was I took the pin, stuck it in the slot here, took my parallel pliers, had it at a bit of a different angle, and I just gave this a really light squish. Gave the aluminum a light squish on each side. If you look closely, you can probably see my little squish marks there. And all that did was take up that little bit of slack on the aluminum arm. Now these aluminum arms are going to wear out over time. We're going to put some lubricant on them. You want to make sure you keep them well lubed, but the steel pin that goes into here is not going to be as quickly worn out. Maybe it will, but that's easy to replace as these arms. So, you know, maybe 50 flights, 100 flights in. Every flight you're just checking your surface movement, and maybe eventually you do a replacement set of these things. That would be another good part to keep on an airplane like this. You can see here we added red Loctite, so I put a light coating of red Loctite around the shaft, and then of course we put red Loctite on the threads as well. So that red Loctite will also activate between these two surfaces and hold this arm in place. So now let's install this with a really tight fit and see how it works. So now we're just going to go in and we're going to adjust that servo so it's centered. There we go, that's pretty good. So now there is, this play you're seeing in here is in the system flexing, but before it was going clunk, 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 clunk because of that movement. So now it is tight. You can see the whole table shaking as I move this. Perfect. So that was definitely a tip time, and this tip time has been brought to you by trusty bent screwdriver. All right, so first vertical, man, those things are massive. Look how huge those things are. You guys need some reference here. First vertical is done. We haven't bolted it in or anything, but it's done. We got to take it back off because we got to do the elevator. So this one's done. We're going to do the other side now. It's going to be an exact match. We know the plan, we know the system. Let's get the other one done now. Right rudder is also complete. So both of our rudders are done. Left rudder has the light wire coming down. So I haven't done anything with the wire yet, but I wasn't worried about that. I was worried about the movement of the surfaces first. So now what we'll do is we will take our rudders off, or the right rudder off, and we'll start getting focused on our elevator surface. So elevators on the SU are a little bit different. So what happens when you want to take these elevators off, they're clipped in with the normal Skymaster key hold retaining system here, which is awesome, but they're also attached to the control arms which come through this slot right here. So you've got your servo mounted there, you've got that massive control arm coming up, that carbon center hub one. Your control arm comes back and mounts to the horns on the surface itself. All right, so one of the real downsides with these Skymaster kits is they don't give you any dimensions or anything like that. So something like these elevator control arms and system here, it's a little hard to follow, so you have to be quite careful. So as an example, these actual surfaces may look like they are flippable, but the top side has a little bit more of a lip on this surface right there versus the underside right there. So on this scheme, you've got the little bit of silver on the leading edge, and then if we flip it over, there's a large section of silver. So I figured out which way is which. When we're putting these together, the control arms and everything, it's a little bit of a figuring out process. Now these control arms are pretty much fixed because everything's threaded. So these little pieces here, we're going to thread these in with Loctite into the ball joints, and then our aluminum threaded piece here connects those two. So that's pretty straightforward. I'm assuming they kind of have some pictures with some ruler in place, but it doesn't really make a whole lot of sense when you can't see the ruler. So I'm assuming that we're going to be positioning this with our pivot point of our ball here right over top of our shaft. but I think what's going to determine that position is the servo position with the control arm length pretty much fixed as well. So this is kind of a fixed dimension here that we need to be mindful of when we're putting this together. So just kind of doing experimentation at this point. I'm going to use red Loctite, thread these guys in. One side has an Allen key, one side is solid, so the solid side goes in, so you can tighten these down with an Allen key. So we're going to get that all put together, and we'll start kind of playing around with this and getting some measurements done. All right, so we got our horns installed on our servos, and next thing we need to do is get our servo installed, but we need a slot for the horn to come through. So what we do is simply transfer the lines for the servo opening onto the tape, and then use our depth gauge. This line here equates to the plywood that the servo is going to mount to. So now we can lay our servo here and get our area marked out for our servo arm. Okay, so we've got everything ready to do our cutouts here. So the heavy line in between the two lines that are like that, that's our cutout initially for the servo arm. The servos don't fit in these through the openings here. We have to sand the openings out to actually get the servo in. We may have to pull the servo arms back off in order to get the servo and arm and everything back in, which is totally fine. That's not an issue. So first step here is going to be opening this up just a little bit. And then we'll also at the same time Dremel our little channels here, so at least that part's done. All right, so we got our left servo installed. A couple suggestions here if you happen to be building this plane. Servo pockets are very tight. That servo does fit in. It takes a bit of wiggling and manipulation, but it's better to be tight. So when that servo's in there with no screws in, it doesn't move at all. So that is amazing. Again, we use those big Mamma Jamma screws, and this is absolutely rock solid there. We did have to put the servo arm on afterwards, so what I did there is I got it powered up without the arm on, so the spline was this way, took the power off, kind of jammed that on and rotated it down, installed the servo arm, powered it back up, and just confirmed that it was straight. So I also had to extend the channel here because our servo arm has to go on and then be able to straighten out. So that's not a big deal. That's all hidden by the rudder as well. So, but yeah, so that is our left servo. So we're doing a little bit of layout here. We also got the servo mounted in the right side of the aircraft. Much easier once you have things figured out on one side. Very easy to repeat on the other side. So a couple important things with the layout here. This is all sort of explained in the manual, but there's a good online thread on RC Universe. So the elevator neutral is about 68 to 70 millimeters down from the joint. So we've put tape on each side and marked that out. So that's elevator neutral. Follows the underside of the fuselage here pretty closely if you need just a kind of a reference mark, but that's neutral right there. So what I've done is I've put the vertical stab on, just kind of place the horns here in place just to kind of get a general outline. And there's a couple pictures in some of the build threads shows this about, well, it's also shown in the manual, I think, but it's not clear. It's about 4 millimeters in from this edge. So all I did was put those horns in there, draw a pencil mark on each side, and that is roughly about 4 millimeters in on each side. So that's kind of what we're looking for. That's also going to bring us into the structure of the horizontal stab because there's a hollow pocket right here, and then we've got our structure starting about there. So I just wanted to do that to kind of get some lineup guidelines. So we pull this out, and the other thing I was checking was how this sits in there. So we're kind of looking at about something like that. What I was playing with here was just making sure we get our movement and have that kind of all the way forward. Now, one of the things I was thinking about when doing this is when we go to full elevator down, which is going to be something in the range like this, what I want to make sure is that fairing piece doesn't pop out of the receiver piece, right? We want them to always be interlocking with each other. So that's why I'm kind of playing around with position on this thing as well. Now this is going to have to get opened up when you mount it. The whole bottom's going to have to get, well, at least to fit on the carbon horns is going to have a slot put in place. So, but your removal, this piece stays on permanently. Your removal is from underneath the vertical stab. So you lift the vertical stab up, undo that bolt, and then you could just pop the vertical stab back down. But, or you can take it off, of course. So now that we kind of have our layout here, I'm probably gonna do my slots now and get this all fit. Now, one of the things that's fairly critical in position here with everything being laid out is I want my neutral to be neutral, my servo arm to be straight up and down, close anyways, and I want this to be in the right position so our fixed length arm is perfect to that servo arm. All right, so we've got our area marked out here. Essentially what I did was initially I kind of had the marks here. That's okay, but the problem is that you're in front of the structure. So what I did was I just took those marks, moved them back. That is the starting point for our horn installation. So it's nice to know that that's kind of the layup here. So I've got my Dremel with my carbide bit, and that depth is set to the depth of the tabs. So we're gonna make 2 slots here. You could probably do one big one, but we'll start off with 2 slots and confirm that that fits perfect, and we'll go from there. All right, so a little shot inside there for you, if I can pick it up on the camera. So basically, this entire area is balsa, and that somehow goes into the actual stab as well. So it kind of goes in. I don't know what's past here, obviously, but you've got balsa in this area. So what we'll do in this case, now that we've got our slots done, is we will soak this balsa in thin CA. It's always a good thing to do in this case. That makes that structure a lot stronger. And then we'll be high soling these control horns in place. Now, just for geometry here, the pivot point essentially comes to right over top of the pivot point of our stab, which is basically perfect. All right, guys, so a bit of a running change here. What we're gonna do is we're gonna change the arm that came with the kit to a standard MKS arm. Now, there's a couple reasons we're gonna do that. Number one, the MKS arm is about almost double the thickness. I'm not going to bother measuring it, but the other thing is the stock Skymaster arms, this hole, the screw that actually fits through there just slips right through. The MKS arm is a much smaller hole, but this middle hole on the MKS arm lines up with the outer hole on the Skymaster arm. So what we're going to do is we're going to tap that with a 3mm thread. What the owner of the plane is talking about is when he puts his current one together, there's a little bit of play here because it's already a loose fit. And if we tap this, it's gonna end up just being a tighter fit overall, which is what we're after. So that's a good change. We did order these for this kit, so we will end up using them now because just it's a better way to do it. So that's an awesome change. Highly suggested. So we've mixed up a whole bunch of 9462 high sol. We've got the left side glued in here already. So what I'll generally do in this case is I will just put a whole bunch of high sol in there. Of course, fill the holes, cover the tabs with high sol as well. Insert it, and then I'll use a little bit of CA just to lock it in place. So right now this is stiff, but that's just the CA holding it in place. I'm just going to do the other one here, and then I'll take a gloved hand or finger, and I will come back and just clean up our edges. This all is hidden anyways, but we want a nice clean edge for our fairing piece to mount on. So, but that's basically how we glue it. My suggestion during this is resist the temptation to use a nozzle with your gun. You really want to make sure you get good glue mixing. So I always, in this case, will mix it in a tray and then just use trusty bent screwdriver here and just jam a whole bunch of glue down in those pockets. And usually when I do this and insert the arms, you get a bunch oozing out. In this case, it won't happen because there's a big open pocket in here, but at least we know we got a whole bunch of glue in there and it's good mixed glue. So those horns are both glued, and we're just going to let them do their thing. You can see I cleaned up the sides here. You want to make sure you do that so the fairing can go on, of course. So we don't want to touch those until they are firmed up, so we'll give them a couple hours to firm up, and then we'll be able to work with them, obviously not putting any force on them. So next thing to do here is pull the servo arm off, the stock one, and get it switched out for the aftermarket one. All right, so you can see there we've got the horns stacked together. The middle horn on the MKS servo arm lines up perfectly. So we're going to tap that with a 3mm tap. And we're also going to sand this carbon horn down a little bit just to make sure that we're not dealing with any interference issues. So we've got our left horizontal stab installed here. One thing I did to minimize the amount of sub trim is I took our servo arm and went 1 notch towards the control arms. Obviously these dimensions are basically fixed. I wouldn't want to take our control arms and move them forward because then we're minimizing our glue area. Obviously we don't want to be adjusting our control linkage here to a different linkage unless we change the actual materials. And the other thing is at full travel we are getting pretty close to the front edge of our slot. So with that notched backwards now, 1 notch, we've got more clearance and that won't affect anything. So I needed to add about 13 points of sub trim in there, and that gets us right in line with our 0 mark. All right, so I'm pretty happy with the setup. I think it's going to work wonderfully. Our orientation is quite important. The manual kind of shows the rod on the outside and stuff, but of course, because we switched our arm, it's a little bit thicker. Everything gets a little bit tighter in here. So we've got to run our control arm on the inside, and our button head goes on the inside, and our nut goes on the outside. Now I've already put our vertical stab on here to confirm, and this works out perfect. So what I did was I put a little label right there. So button inside, nut outside. So right elevator is now done. We ended up with the exact same orientation on our rods and everything. So let's check how this thing looks. I'm just being careful because our high sol is not fully cured. So here is elevator movement. And aileron or taileron movement. Beautiful. So next thing we want to work on is our covers that go on here. So let's gather those up and see what we need to do. So we've got our powers all off. Our elevators are sitting at neutral here. And what I've done is basically line it up back a little bit here. So the leading edge of our fairing piece comes to the leading edge of our carbon horns, just like that. Put a tiny little mark on there, and then we've got our Sharpie mark. So what we'll do now is we are going to do some dremeling and sanding. We want to leave as much of the edge piece on as possible. So this is going to be a trial and error type thing. So I'm just drawing this out so you guys can see what I'm doing. And the reason we want to do that is that also leaves us with some gluing surface. So we're going to use shoe goop to hold this in place. Nice thing about shoe goop is it's going to go on here, it's going to be invisible. It's permanent, but it's non-permanent. So when we glue something like this on with shoe goop, if we really need to get this off, we could take a piece of safety wire, run it under the back here, run a razor knife along the sides, and this will basically come off. But during normal flying and the plane being operational, definitely won't come off. So we're going to Dremel that out next, and then we will see how this fits. All right, so we pretty much have this fit. A couple considerations. I had to go a little bit further than I originally planned here. So there's my original mark right there. You can see how much further we went. So the reason for that is you have to get enough of this inserted underneath the vertical stab, so when the elevator moves this direction, it actually rotates over top and hits the angle coming down. So what that ends up looking like, we've got a little pencil mark on the back here, is something like that. So that actually works good, I think, for positioning, partly because we still have reasonable access to this fastener if we ever were need to take this fastener out. Now, one of the things I've noticed here with these stabs is if we go all the way to the extreme, we're probably not going to be there very often. I'm just going a little bit further. I'm not sure how far the servo actually moves. We can plug this in and check. But right now, the ball joint is hitting on the carbon. Don't want to add any spacers to that. So what I'll do is I'm going to plug the servos in and just check and see if that actually is interfering. If it is, we can take our Dremel and just sand a little bit of that arm off. And we could also take a little bit of the carbon off, maybe a combination of both. We'll have to see what works out best, but very close to fitting these two covers on there. Okay guys, so one of the things you really want to make sure you do on this kind of setup is what I'm going to show you here. Now this servo has so much force that you have to be careful with a setup like this. So to give you an idea, here's aileron control, here's elevator control. Now you got to remember that we've got both available. So there is bottom left-hand stick. That's just left aileron, that's just elevator. There's both put together. So right now, that position is the mechanical limit of this horizontal stab surface. If we overdrive this system, something's going to break. So if we have that servo set up to travel too far, mechanically something's going to give here, whether it's the horns pulling out or something cracking, whatever is our resistance point right there, right? So that's our mechanical limit of the surface travel, and the top of the surface hits right there is what I can see. So, and also our carbon arms are getting very close to the surface. So what you want to do is you want to go in and, I think most radios have this, but you've got the elevator servo here, max positive and negative, that is on the elevator movement itself. And then you've got max positive limit. So that is the absolute limit that the servo can travel with other inputs. So if we go aileron elevator, this sets the max positive limit. So if I take that and dial it down, the servo starts to move. So the servo starts to move, we can reduce the travel. But what I want to do is, we're at our max positive limit, but I don't want to be able to go any further than that. So I've set both of these numbers, or I will set both of these numbers, just to keep this healthy and safe. So no matter what we do, mechanically we can't go further than is actually available. So we got our other cover here done, and what I did was I just took my Dremel and just got rid of the paint in this area. That's where our primary sticking surface is going to be for our fairing cover, and this is ready to glue once we've got everything done and figured out. All right, so we've got the tail fairings ready to glue in. Our tails have all been put together here. We've got the rudders actually screwed and fastened in place. We've sanded the bottom of the fairings out to get rid of the paint, and we are ready to use our shoe goop and get that stuck into place. So we're just going to let this sit while the shoe goop cures, and that is going to be the last step on this tail. So we also had our pilots arrive here as well from Warbird Pilots. Thanks guys for getting us these pilots. So these are the 12-inch 1/5, 1/6 scale. They do have operating heads as well, so both heads have a servo in them. I don't think we have got a randomizer. Didn't think about that. So no randomizer in the package. But these are the whitehead pilots with black suits and green G suits. Look very nice. And there is all of our parts glued on for our horizontal stabs. So here is why I love using goop. So you can see there, it's kind of oozing out of the bottom. So what I do when I put this on is I actually put a bunch on the sides and then put some on the little contact piece here that we sanded. And then when you install this, that stuff on the sides actually flows down, and it will fill all the gaps in the bottom, fill the space between the carbon and this thing. So it actually is really cool because you put it up here, give it, a couple minutes and it's flowed down enough. So works really well. And then all this excess here, once it's cured, we'll just be able to rub that off, no problem. And there's a shot of the right side there. So tail section on this aircraft is done. All right, so last thing I want to take a look at here is the Stinger. I want to see how this operates, just confirm obviously that it does work. So I'm going to get this all wired up. It's pretty straightforward. So it uses a JP controller, it looks like. I guess we would treat it as one of the wheels. So we'll just treat it as the front wheel. Power in, servo in. And so we'll get this wired up and let's take a look at it. Okay, so our chute is all the way, or our plunger is all the way down there. Now the way this was programmed originally from the previous model was the actuator pushes out and then returns. So because this is electronic, it also accomplishes the same thing, and it won't operate again until you reset the switch. So I'm going to cycle this now. So we reset the switch and chute should operate. 3, 4, 5. So about 5 seconds, and then the plunger returns. Perfect. So, and this switch is all on this one right here, this SM switch. So right now, if I go back, that's resetting, and then now it's going to operate again. 1, 2, 3, 4, 5, 6, 7. So about 6, 7 seconds for that to fully travel. It comes to about here, and I think it resets to about here. So those chutes should come out probably after about 4 seconds of that being cycled. All right, and while we got our back end electronics out, let's take a look at how the vectored thrust nozzles operate. So this is marked as the left one here, so we will, let's get this thing plugged into the central box and see how she works. All right, and here is our left vectored thrust nozzle. So no movement is set up left to right. We just have our pitch access, and that's going to be sitting like that. It's skewed a little bit with how it looks inside, but there is up and down. So not a ton of movement, but this is enough that it's going to make takeoff much easier. Now the way this is set up, it only works in takeoff flaps. So that's the way it's currently set up. So you can see there, we're in takeoff flight mode. It's operating. If we go to landing, we got nothing. If we go to regular flying, we got nothing. But the servo, of course, is still holding everything in place. Those are super cool. All right, guys, and that is everything for this episode number 3 of the Skymaster SU30 ginormous aircraft in Russian white scheme. So we got all the back end stuff done. We took a quick look at the tail cones, the vector thrust nozzles, and the Stinger. So a couple things for you guys. First thing is don't forget to check out the lighter side of RC After Dark. We're so far ahead in videos right now that if you're watching tomorrow's After Dark, this video is way in the future, but if you're watching tomorrow's After Dark, we're like getting close to wrapping up the SU, and there's been no videos actually even released at this point. That brings up another point. We have channel memberships available for you guys. A feature that YouTube has added recently is that we can release to channel members videos early. So as I'm recording this video right now, I have 2 of the upcoming videos sitting in channel membership section. And if you guys have a channel membership, you can watch the videos early. There's a lot of times I will have videos uploaded days and sometimes even weeks in advance. So if you're interested, it is a paid service. There's a link down below to channel memberships, but from the homepage, you can see the channel membership button there. And I know I'm covering a whole bunch of stuff at the end here, but this is the only time that I think it's reasonable to fit it in. We also are starting a podcast. Me and my friend Anthony, we are starting a podcast channel. It's a completely separate channel called the RC Air Experience, or just RC Air Experience. It's going to be just a podcast channel. We've got our first 4 podcasts already lined up. We're in the process of organizing things right now, and it's a place to have interesting people in the hobby, suppliers, manufacturers, to come in and do an interview podcast style with us. So keep an eye out for that. We'll be announcing those things as we go forward. The SU30 is coming along very nicely. We should have a major part of this aircraft done in the next couple days, which is awesome. We will be waiting for the engines to be delivered, which is going to be a bit of a delay, but that'll be obviously in the final video. We'll be doing that stuff. So thanks guys for watching. Next video, we are going to still focus on the back end, get our stinger figured out, get our vectored nozzles figured out, start working on the wiring of all the items we did last time and start running that stuff forward. So don't forget to keep an eye out for that episode. Thanks guys for watching, and we'll see you in the next video.